Okay, so let's dive into this incredible story of a hidden control system, a secret GPS, really, running inside our own brains that guides one of the most agile parts of our body, the tongue.
I mean, really think about that for a second. Every time you talk or eat, your tongue is pulling off these insane acrobatic feats. We're talking about hundreds of lightning fast, totally unconscious adjustments every single day, all while somehow avoiding a painful collision with your teeth. How on earth does it do that?
Well, it's all about this rapid touch-guided correction. You know, if your finger just brushes the edge of a coffee cup, your brain instantly recalculates and adjusts your grip without you even thinking about it. Your tongue is doing that exact same thing, just way, way faster and more often. And for the longest time, the brain circuits that pull this off have been a total mystery. So to crack this case, scientists came up with this just brilliant experiment. They used mice, and they tracked their tiny tongue movements in glorious 3D down to the millisecond to really see this process in action. So here's the setup. A mouse licks a water spout, pretty simple, but then, plot twist, the spout suddenly moves just a tiny bit. This gives the tongue a little unexpected nick on its surface. The whole experiment boiled down to one simple question. How is the tongue going to react on the very next lick? Now, whenever neuroscientists are hunting for the part of the brain that controls a really complex, skilled movement, well, there's always one usual suspect they look at first. And that suspect is the cerebral cortex. You can think of it as the brain's thinking cap, right? It's the high-level CEO that processes all the info from our senses and then makes decisions to execute these precise, voluntary actions. So logically, the parts of the cortex that control the tongue's feeling and movement, they have to be running the show. So the scientists did what any good detective would do. They put their prime suspect to the test. And the way they did it was just genius. They used this amazing technique called optogenetics, where you can basically use light as a remote control to switch specific brain cells on or off. So with perfect timing, they could temporarily shut down the tongue's control center in the cortex. Essentially, they sent the brain's CEO on a surprise vacation, right at the exact moment a critical decision had to be made. So the big question is, what happens now? I mean, with its main command center offline, you'd expect the tongue to just fail, right? It's got to miss the target, or at least get clumsy. But then came the big reveal. The tongue re-aimed perfectly. It didn't miss a beat. And this was the first huge twist in the story. Our prime suspect, the cerebral cortex, it has a rock-solid alibi. It is not essential for this super-fast correction. Okay, so if the CDO didn't do it, who did? This stunning result meant the real culprit was hiding somewhere else, lurking in a much deeper, more ancient part of the brain. The investigation had to go on. And this is where a new person of interest enters the scene, a brain region called the superior colliculus. Now, what's so interesting is that we already know this area is famous for orienting our head and eyes towards things we see. So the scientists had a new theory. What if it's doing the exact same thing for the tongue, but using the sense of touch instead of sight? So they put this new suspect to the test. And this chart right here, this is basically the smoking gun. That first tall bar shows that when they turned off the cortex, the tongue still made a big, successful correction. No problem. But look at that second, much smaller bar. That's what happened when they shut down the superior colliculus. Boom. The re-aiming was basically gone. They'd found their culprit. But okay, finding the culprit is one thing. The next big question was, how is it actually doing this? How does this little part of the brain work like such a sophisticated GPS for the tongue? And the answer, which you can see in this quote from the actual study, is just incredible. This region has a map, not a road map, but a map that instantly translates touch sensations directly into movement commands. It's called a mechano-sensoromotor map, which sounds complicated, but just think of it like this. Mechano for touch, sensory for feeling that touch, and motor for movement, a touch-to-movement map. So for the final definitive proof, they decided to see if they could hijack this map and steer the tongue of themselves, like a joystick for the brain, right? They ditched the water spout completely and just used their light switch technique to directly activate tiny specific spots inside this brain map. And you know what? It worked, like unbelievably well. When they activated a spot in the back of this map, it made the tongue shoot way out to the side in a perfectly predictable way. Then, they'd stimulate a spot a little further forward, and the tongue would aim much closer to the center. It was a perfect topographic map for aiming.
It's the same kind of map this part of the brain uses for our eyes, but it's been repurposed for the sense of touch on the tongue. Case closed. All right, so a secret tongue GPS in a mouse's brain. Super cool science for sure. But what does this actually mean for us? Why should you care about this hidden map? Well, it turns out this is a huge deal. This gives us a fundamental insight into how our brains pull off all kinds of fast, unconscious skills. Things like speaking fluently or even just swallowing without choking. And if we understand this system, maybe we can find new ways to help people with neurological conditions where this kind of motor control breaks down. And maybe the most mind-blowing part? It shows that these ancient, so-called primitive parts of our brain are running these unbelievably sophisticated programs in the background, just keeping us going every single second. And that leaves us with a really fascinating final thought. If our tongue has its own secret GPS, what other hidden maps are running our bodies on autopilot right now? It's like we're just beginning to peek behind the curtain at this incredible, invisible world of control that's happening inside all of us.